You know, we should discuss about the system calls a little more before we are ready to write the code. And so this one would be like the last video on theory, and then we dive into the code. In fact, even in this one, we'll take a look at some code, although we won't write the code. All right. So we were talking about system calls, and this was a way for user space uh, to kind of talk to the kernel space. And in the kernel space, then I mentioned that there are drivers, and the drivers would need to implement these system calls. Now, what I want to specify very specifically is that the drivers typically implement two types of system calls. Like the kernel also has like other code, the infra and the process management related code and all of that, which also implements a lot of or not implements, but it's dependent on a lot of system calls, right? So there are some system calls, for example, fork, that can take the current process and create like a replica of that process, and that's process management related system call. But then the device drivers implement system calls which relate to file operations. So we talked about read and write, for example. So those system calls, for example, are file operations related. And again, what is the link between file operations and a device? We'll come to that. Like, what is the different or relation between hardware and file operations? The other thing is they kind of implement hardware management um, related system calls, for example, the IOCTL or input output control, also called ioctls, right? All right, so now let's spend some time on this, and then we are good to go and write our first driver. So turns out that Linux uh, uh, typically treats everything as if it is a file, right? As if it is A slash B slash C. So everything in Linux is a file, and then on a file you can perform certain operations, like opening the file, closing the file, reading the file, writing the file, seeking into the file, so on and so forth. So turns out all of the interactions that you might want to do with the hardware also kind of fit this notion of open the hardware, read some content from the hardware, write into that hardware if required, and then kind of if depending on what kind of hardware it is, you can also do some sort of a seeking, and then we just close that hardware. So pretty much that's all. So what Linux does is Linux will map a hardware, it'll expose it as if it was a file, right? And if it exposes it as if it was a file, then we can do file operations on it. And so as you can now imagine, the drivers are going to implement what to do when the hardware is being opened, what to do when the hardware is being read, what to do when the hardware is to be written to, right? So all of those functionalities will the driver will need to implement those as these file operations related system calls, right? So that is one thing. And now the other thing is that drivers can be of majorly three types. One is called the character driver, the other one is called the block driver, and the third one is called the network driver. Right. So we are specifically going to take a look at character driver, because once we know how to write these, the character drivers, it becomes easy to write the block and the network drivers. Now, what kind of drivers, are within the category of block? Well, file system related, or rather, drive related, your hard disk and solid state drive, storage related, more appropriately, right? So storage related drivers are block drivers, for example. Then network drivers are the drivers that deal with Ethernet and so on. But we are going to look at the character drivers, and somewhere we are saying that a driver or device is exposed as a file. Right. So the interface for the user space to request the call to the kernel space is to do some operation on a file. Right. So let's say, for example, we have, okay, let's take an easy example. Let's say we have a UART, right? A UART is universal asynchronous receive transmit module. You can send like a byte at a time to other computer and so on and so forth. Uh, Pretty old protocol, but still actively used. So let's say this UART is reachable, or the driver handling this UART responds to reads and write onto the file called TTYACM0, for example, right? So as the user code or user application attempts to read this file, the read on this usually triggers the read system call implemented by the device driver for UART. And within this, then, what will happen within this, it will have the functionality to go read some information from the UART and then pass it back to the user code. Right? So this is how we go from user code to kernel code or kernel driver via system calls, and the system calls are triggered by doing read and write, or by doing some operation on the files, right? So this is also very, very key, that a device driver is triggered by doing file operations on a file, and that file is kind of representing access to that hardware, right? And now let me just quickly we'll get rid of this, and what we have here on the screen is a file from the Linux kernel, which is the fs.h. And actually let me go ahead and zoom this in, right? So, oh wow, okay, zoomed a little too much. And let me go down here, right? So this file is called the fs.h, and then on line number 1999 we see these file operations, and within that we have the seek, the read, write, iterative something, read, iterative write, then some polling, some poll here, so on and so forth. There's open here, there is release here, which is same as, I think, same as close, and there is flush, so on and so forth. And all of these are operations that we can do on a file. Right. And as we'll see forward, file operations is something that we'll need to kind of implement while writing a driver. Right. So again, the takeaway from this video should be that user space talks to kernel space using system calls, and the device drivers implement majorly two types of system calls: one that relate to file operations, and the other that relate to hardware access, which is, or hardware management, which is IO control or IOCTL, right? All right, so with this, we pretty much have the imagination and the background we require to be able to dive into writing a loadable kernel module. And in the next section, we'll start with our first loadable module.